Hello everyone, here is Mustafa. This is our fourth lesson in Unit 7 Equilibrium. We'll speak in this video about Le Chatelier Principle. Let's get started. Okay, let's go ahead and speak about Le Chatelier Principle. When a change is applied to a system in a dynamic equilibrium, okay, so we should have a system at dynamic equilibrium. The system reacts in such a way as to oppose the effect of the change. So this is the most important thing in this principle. When we have a system in a dynamic equilibrium, something happened, the system will react to oppose the effect of the change. Let's check this reaction. We have here this reaction. 2A plus B2 is giving 2AB, and this is a reversible reaction. They're already telling us that it is an dynamic equilibrium. We have here Kc, which is the equilibrium constant, the concentration of the product to the power of its coefficient, concentration of reactants to the power of its coefficient. Okay, let's check the conditions that we have here, or the questions that we should care about. Increasing the concentration. Of course, they have to be specific here. So let's say that they will tell you what will happen if you increase the concentration of A. If you increase the concentration of A. Where is A? Here's A. So if we increase the concentration of A, the reaction will respond to oppose the effect of the change, so it will shift to the right. It will shift to the right hand side. Right hand side. We care a lot about two things here: the position of equilibrium and the equilibrium constant. So how the reaction will respond? It will shift to the right hand side because the reactants one of the reactants increase, so it will shift to the right-hand side to oppose the effect of the change. What will happen to equilibrium constant? Equilibrium constant is already here, the concentration of the product to the power of its coefficients over the concentration of reactant to the power of its coefficient. If we increase the concentration of the reactant, the concentration of the product will increase. So nothing, no change. No change to the equilibrium constant if we increase the concentration of one of the reactants or products. Okay? What will happen if we increase the pressure? Okay, what will happen if we increase the pressure? We have, just imagine that we have here gases. So we have here a system. This is in a system, and we increase the pressure. What will happen if we increase the pressure? The system will respond to this change. How it will oppose the effect? The position of equilibrium will shift to the direction that has fewer number of moles. How many moles? Here on the left hand side we have here 3 moles, 2A and 1B, so we have 3, and we have here 2 moles. So what will happen? It will shift to the side that has fewer moles, so it will shift directly to the right hand side. What will happen to the equilibrium constant? Nothing will change. Nothing will change. Okay, let's move to the temperature. What will happen if we increase the temperature? Here we have to stop. Why? Because increasing the temperature here is depending on the reaction itself, is whether it's exothermic or endothermic reaction. So they might tell you that this delta H of this reaction is negative 100 kilojoule per mole. What does it mean by negative 100? Okay, it's exothermic reaction. What does it mean by exothermic reaction? We have here heat. So we have here heat as a product. So when they are telling you what is happening to the reaction, what will happen to the position of equilibrium or equilibrium constant when you are increasing temperature, you have to check whether the reaction is exothermic or endothermic reaction. If it's exothermic, so we have here heat as products. Okay, what will happen if you increase the heat, which is available in the product side? of course, the reaction will shift to the left hand side, considering that we are speaking about exothermic reaction. If it's endothermic reaction, so it should be the other way around. What will happen here to the equilibrium constant? Oh, there is something here interesting. What is it? When we are increasing the heat, we are increasing heat. We did not affect the concentration of the products, but the response increased the concentration of reactants. So we increased the heat without increasing the concentration of the products. Okay, but what has happened is we increase the reactants. If we increase the reactants, it means that the equilibrium constant will decrease. Okay, what will happen if we are adding a catalyst? If we are adding a catalyst, the catalyst is speeding up the chemical reaction without changing itself, so nothing will happen to the position of equilibrium. Speeding up the reaction in both directions, nothing will happen to the position of equilibrium, nothing will happen to the equilibrium constant. So to summarize what we have covered, we have here this reaction. 2A plus B2 is giving 2AB. If we increase the concentration of one reactants or product, what will happen to the position of equilibrium? Shift to the opposite direction, increasing the concentration of, for example, if we increase the concentration of the reactants, it will shift to the product side. If we increase the product, it will shift to the reactant side. So it will shift to the opposite direction. What will happen to equilibrium constant? Nothing. If we increase the pressure, shift to the side with the least moles of gas, and nothing will happen to Kc. Increasing the temperature, here it is a bit tricky, so you have to be careful, because if it's exothermic or endothermic, if it's exothermic, so we have heat as product, so increasing heat. When we have heat as a product, the reaction will respond by shifting to the left-hand side. Okay, if we go endothermic, so we have heat as reactant, so increasing it will make the reaction shift to the right hand side toward the products. Of course, temperature is the only thing that will affect the equilibrium constant. If it's exothermic, if you are increasing the temperature on an exothermic reaction, so the equilibrium constant will decrease. Endothermic equilibrium constant will increase. Exothermic decrease, the equilibrium constant will decrease, but for endothermic reaction, the equilibrium constant will increase. What will happen if you're adding a catalyst? Nothing will happen, no effect, no change on the Kc, no effect on the position of equilibrium.